Okay, so in the next video or two videos, depending if I have to split it up for time, we're going to talk about reflections. Okay, reflections, rotations, and translations, I should say. So the first one we're going to talk about is reflection. A reflection, again, is just when we take a figure and we flip it over a given line, whether that be an x-axis, a y-axis, x equals a number, or y equals a number, so on and so forth. So the first example you're provided with, there's some tips I'll put in this packet throughout just to say, oh, if you reflect over x, you just make the y's opposite. You could do that, but the easiest way to do this that will work every time, no matter what line you're given, is just to count to and from your line of reflection. So if I'm given that this is my line of reflection as my x-axis, okay, then to do the transformation, what I want to do is I want to go ahead and count how many spots away I am from that line. So if I'm at this point, I'm only one spot away from that line. So to reflect that point, I want to go one spot in the opposite direction. Okay, and that gave me my new point. For the next point, I was 1, 2, 3 spots to the line. So I want to continue 1, 2, 3 spots in the opposite direction. And I can continue to do that. To get from my figure to line of reflection was 1, so I want to go 1 in the opposite direction. 1, 2, 3, which means I want to continue 1, 2, 3 in the opposite direction. So that's how I got these points, which I can then go ahead and connect, okay, to get my new figure. Okay, so this is an example that's provided. Let's look at two quick practice problems. All right, so first we have the directions to label the x and y axis. So of course we know this is our y and this is our x. All right, and it says to label each of the points, so we can go ahead and do that. This would be 1, 2. This would be 2, 3, 4, 5, 3. And this would then be 1, 4. Now it's telling me I want to reflect the shape across the x-axis. So in this case, my line of reflection is going to be the x-axis. Okay, which means when I'm going to reflect this, I can go ahead and count from one of my original points. I would be going down 1, 2 to get to my x-axis, so I want to continue 1, 2 in the opposite direction to get my point. From here, I'd be going down 1, 2, 3 to get to your x-axis, so again, I want to continue 1, 2, 3. And my last point up here, I'd have to go down 1, 2, 3, 4. So again, 1, 2, 3, 4. And a little hard to see, so let me just change the color of these points. Okay, we had 1 point here, we had 1 point here, we had 1 point here, and so if we connect those 3 points, that would give us the reflection of our triangle. So a couple things. It's not perfect, obviously, because I'm writing on this kind of crazy screen thing, but as you should be able to tell on your paper, especially if you're using a straight edge, your triangle should be exactly the same shape and size that it was before you did the transformation, okay? So that's not changing at all, just the location, sometimes the orientation in which it's pointing may be changed. The other thing I want you to remember is that if I had labeled this, if this were A, B, C, for instance, my new image would be A prime, B prime, C prime. And this guy up here would be my pre-image, and my new figure down here would be my image. Okay. All right. Next problem. Same idea. The first thing we're going to do is we're going to label our x and y axes. So we have our y going like this. Our x is over here. We're labeling each of the points. So up here I have -2, 0. Over here I have -2 and 1, 2, 3, 4. And back here we are at negative 2, 3. And again, let's call these A, B, and C. Next, we're told we are going to reflect again across the x-axis. You'll see the other two are again across y for your practice problems, so be careful to make sure you're looking at the right line. And the next thing we're going to do, we need to reflect this. So, for my reflection, if we look at point C first, okay, point C is already on the x-axis, which means I moved 0 places to get there. So I'm going to move 0 places for my point of reflection. I don't have to move if my point's on the line of reflection. For point A, I went down 1, 2, 3 boxes. So I'm going to continue 1, 2, 3 boxes. Oops. And that gives me A prime. For B, I had to go down 1, 2, 3, 4. So I'm going to continue 1, 2, 3, 4 in the opposite direction, and that gives me my B prime, and of course we already had our C prime, and I can connect my points to get my new triangle, which again, a little bit nicer you're doing it on a piece of paper with a straight edge. Okay? Alright, so that's it for reflections. You have some more practice problems on your paper which you can complete. Pause this video, go ahead and do this, and if you only have to complete up to reflections for homework, then this is where you would stop. Okay? Translations. Translations are the easier of the two. This is where we're going to slide our figure around somehow. And there's 2 different notations we're going to use for that. I'm going to put them on here. You're going to have to add them into your notes. So to translate this regular trapezoid went down, it says went right 7 and down 5. Okay, so let's look at this. Translate this regular trapezoid right 7 right and down 5. So we can see already there's kind of a little typo here. This should be 7 left. Sorry about that. Okay. This being my pre-image, this being my image, and I can also tell because there's no prime marks here, but there are, that we went 7 left and 5 down. So for each point we went, for instance, point A, I went over 1, 2, 3, 4, 5, 6, 7, and then I went down 1, 2, 3, 4, 5. And again, we would repeat that for each of these. I'll just do one more. D, we went 1, 2, 3, 4, 5, 6, 7. And we went down 1, 2, 3, 4, 5. Okay, so that left 7 and down 5, you're just taking each point and counting left 7, down 5, and making a new point. Now the 2 notations, if I want to write left 7 and down 5, there are 2 different ways I can do that. Because my left and right is talking about my x-axis, we would do a mapping which says that the points x and y are changing by x is being moved left 7, so negative 7, and y being our up and down would be I'm going down 5. So my y points would all be going down by 5. So this is one notation which is called a mapping. And the other notation that we use is called vector notation. Okay, and in vector notation, all we do is take out all the x's and y's. So if I want left 7, again, x being the first coordinate, telling me left and right, I'm just going to put negative 7, and down 5, I would put minus 5, and that would be my notation for that. Okay, so again, we're labeling our x and y axes. And let's call this A, B, and C again. And they want to move this right 6 and down 2. So for each point, I'm just going to count right 1, 2, 3, 4, 5, 6, and down 1, 2. That's going to give me C prime. For I am going to go right 1, 2, 3, 4, 5, 6, and down 1, 2. And that gives me my A prime. And for B again, right 1, 2, 3, 4, 5, 6, and down 1, 2. Gives me my B prime. And all I have to do is connect these. Okay. Also, just to go over the notation again, because I went right in this case, my xy is mapped onto x plus 6 because I went right, and the down 2 would be y minus 2. And if I want to write that in vector notation, we just take out all the x's and y's, and we have 6, negative 2. Okay. One more example. We have x and y axes. We want to go left 4 and down 6. So again, if I call this A, B, C, D, left 4 would be 1, 2, 3, 4, and down 1, 2, 3, 4, 5, 6. Gives me my A prime. D is going to be left 1, 2, 3, 4, 5, 6, and down, whoops, I went a little too farther. Left 4, 1, 2, 3, 4, and down 1, 2, 3, 4, 5, 6. And we continue left 1, 2, 3, 4, and down 1, 2, 3, 4, 5, 6. And of course, at some point, if you have a nice simple figure like a rectangle, we can kind of already figure that C is going to go right there because, again, remember that these will not change shape or size, so we don't have to worry about that. Okay. Again, you have a handful more problems after this, a practice problem, so go ahead and try those on your own. We're going to end the video here because I'm going to run out of time for rotation, so I'll add one more video later for rotations.